All right, welcome back to the fourth lesson of this chapter. We are going to move on from exponents for a bit. We're going to move on to radicals, okay? Now, let's talk about radicals first before we get into these examples, okay? Let's know the names of, parts of the radical. So let's say we have square root of 16. Now, I know if it's a square root, we do not write a little 2 there, but there is a number there. Okay, so again, if it's not written, it's a 2. If it's written as a 3, like here, then that means it's a cube root, right? If it's written as a 4 there, then it's a fourth root. Recall, cube root just simply means you're looking for a number multiplied by itself 3 times to get to this number inside a radical. Okay, now what's this number inside a radical called? Okay, so there's actually a name for it. This is called a radicand. Okay, so the number inside a radical is called the radicand. Okay, now this number right here, the little number, is what we call the index. Okay, so that tells you what kind of root we are looking at. So again, if it's not written, it's a 2, and it is a square root. If it's written as a 3, the index is 3, that means the root is a cube root, okay? Now the whole thing is what we call the radical. Okay, so when we talk about radical, we're talking about the whole thing. When we talk about the radicand, we're looking at the number inside. When we talk about the index, we're looking at the that little number right there. Okay, so that's basically what the parts of the radicals are. Okay, so now let's see. We are gonna look at some patterns. Okay, so we have here a square root of 4 times 9. Now we all know 4 times 9 is simply, let me blow this up a little bit. 4 times 9 is 36. And 36, the square root of 36, hopefully we know that's just a 6, because again, 6 times 6 is 36. Therefore, the square root of 36 equals to 6. And again, because there's no number written here, the index is a 2. So we're looking at the square root here. Now, let's look at the second box here. We have square root of 4 times square root of 9. Okay, now these two are almost identical, except that, we are kind of splitting this one single radical into two radicals. Okay, and let's see what happens here. Well, square root of 4 is a 2, square root of 9 is a 3, and we know that 2 times 3 is 6. Huh, interesting. That is a 6. This is also 6. I wonder if that's true for cube roots as well. Okay, so you know what? Let's take a look. We have two examples here. We have the cube root of 8 times 125. Now, 8 times 125 is equal to 1,000. And the cube root of 1,000 is equal to 10. Again, this is because 10 times itself 3 times, namely 10 times 10 times 10 is exactly 1,000. Okay, so the cube root of 1,000 is 10. Let's see if this works if we split them, okay? So cube root of 8, that is simply just 2, because 2 times 2 times 2 is 8. The cube root of 125 is actually 5, because 5 times 5 times 5 is 125. And indeed, 2 times 5 equals to 10. Okay, so it also works for cube roots, okay? It turns out, in general, when we have the nth index, okay, nth root of a times b, we can simply split the multiplications, right? We can split a times b, the nth root of a times c into the nth root of a times the nth root of b. Okay, so again, where n is the natural number, so, well, actually 2 or higher, I suppose, right? It's 2, 3, 4, 5, and a and b are any real numbers, okay? Well, it depends, right? I mean, just if it's an even root, then you gotta make sure a times c gets you a positive value. So we can actually use this property to simplify square roots and cube roots that are not perfect squares or perfect cubes. Okay, so in earlier lesson, we look at the perfect squares and the perfect cubes, right? And then we look at the square roots of those numbers and the cube roots of those numbers. But not all the radicands are perfect squares or perfect cubes. Okay, but we do have some factors for those radicands that are perfect squares or perfect cubes. Okay, so for example, we have square root of 99. How are we going to simplify this? Well, if we think about all the perfect squares, okay, we have 4, not all, okay, not all, some, okay, 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100, right? And so on, right? These are the perfect squares. Now, is there any number out of these perfect squares that is also a factor of 99? Yes, there is, right? 1 obviously is a factor of 99, okay? But we don't really look at 1 because, I mean, it's not that interesting, okay? 1 times 99 still gives you the 99. However, we are always looking for the biggest perfect square factor. In this case, it is 9, okay? 9 times 11 is 99. So I can rewrite square root of 99 as square root of 9 times 11, which we learn from this property that we can simply split this into 9, square root of 9 times square root of 11, okay? And then we know square root of 9 is simply just 3. Now, there's absolutely nothing we can do about square root of 11 because there's no more perfect square factors for 11. So we can simplify root 99 as 3 root 11. Okay? Now, this is what we call a mixed radical. Okay? Because it's mixed with a whole number there and a radical. So this is a mixed radical. And this is what we call the entire radical. Entire radical, because there's nothing else other than just the radical, right? There's no whole number in the front. Okay, so this is called entire radical, and this is called a mixed radical. Okay, so let's look at a second example. I'll show you one more. Square root of 72. Again, we're looking for a perfect square factor. Okay, so we can see 4 is a it's a perfect square factor of 72. Yes, but we want the biggest. So we look at the next number, 9. Oh, sure, 9 is also a perfect square factor. But 9 is still not the biggest, okay? 36 is actually the biggest square factor, okay, perfect square factor. So 72 is the same thing as 32 times 2, which then we can break this into 36 times root 2, which then gives us square root of 36 is a 6, and root 2 is simply just a root 2. Okay, now I'm going to show you what if I did not pick the highest or the biggest perfect square factor. What would happen, okay? So I will just show you, don't need to copy this now. I'll show you in this box, and I'll erase it later, okay? So let me pick 9, okay? 9 and 8. Oh, sorry, not 36. 72. If I change this into 9 times 8, right, then we can split this into square root of 9 times square root of 8, which is okay. So then square root of 9 is just 3. Root 8 is root 8. Now you can see this is not the same as that. However, you hopefully recognize that 8 is a multiple of 4, right? And 4 is a perfect square. So we can actually split 8 into 4 times 2. And therefore, this can be rewritten as square root of 4 times square root of 2. And that's multiplication as well. Now, root 4 is a 2. And you can see 2 times 3 is a 6. And you can see now you end up with 6 root 2. Okay, so it's okay if you don't pick the biggest perfect square factor to begin with. It's just that it's going to take one or maybe a couple more extra steps. Okay, and that's fine. There's nothing wrong with that. Okay, it just takes a little bit longer, but nothing wrong with that. But of course, we always strive for efficiency, right? So if you could find the biggest perfect square factor, that would be the best. If you can't, that's okay. We can work, with smaller numbers and then slowly work towards the final simplified version of the radical. Okay, now let's take a look at the cube root. Now, how is that going to be different or similar? Well, the method's the same, right? You're still looking for a factor. Except this time, we don't look for a perfect square factor. We're looking for, you guessed it probably, this is a cube root, so we're looking for a perfect cube factor. Okay, so now let's list out some of the perfect cubes. That's 1. Again, really 1 we don't really, care that much because it doesn't really help. But for sure, 1 is a perfect cube. The next perfect cube is 8, and then 27, 64, 125, 216. I think that's good enough. Okay. The next one is actually 343. Okay, that's probably all I remember. 8 cube. Let me see. That's 8 cubed. That's 512. There you go. Okay. All right, and so on. Okay, that is definitely all I can remember. Oh, 9 cubed, 2140, 2143? I can't remember, something like that. Okay, anyways, cube root of 72, so we're looking for a perfect cube factor. In this case, 8 is a perfect cube factor, and in fact, that is the biggest one. Okay, so we are going to split cube root of 72, first of all, into 8 times 9 for the 72. Then, oops, we are going to split this into two radicals. Okay, so that's going to be cube root of 8 times the cube root of 9. We know the cube root of 8 is simply just going to be a 2, because 2 times 2 times 2, again, multiply by itself 3 times, gives you an 8. Now, don't forget to include your index, okay? That is a common mistake, including myself. You know, sometimes I just left out the index. It is very important to keep it there, okay? All right, so that is how you simplify radicals using perfect powers. There are two examples here, okay? So I'll let you try it, and I'll show you the answer in a bit, okay? Okay, so hopefully you see that 32 can be broken into 16 times 2, and therefore this is root 16 times root 2, and therefore this is 4 root 2. Okay, cube root of 86, or 56, sorry. 56 is the same thing as 8 times 7, so this is the cube root of 8 times the cube root of 7, which we just did. Cube root of 8 is just 2, and the cube root of 7, there's nothing we can do about that. So there's your answer, and there's your answer. Okay, so this is one of the methods I'm going to show you. I will show you a second method, and this one is going to involve, you guessed it, prime factorization. Okay, so we did prime factorization earlier, so well, we can actually use it here again. Okay, and now let me show you how we're going to use this now. Okay, now before we use the prime factorization method, I need to show you this. The square root of 4 can be written as, okay, first of all, we know square root of 4 is equal to 2, right? Okay, but I'm going to show you this. Square root of 4 is the same thing as square root of 2 squared, right? 2 squared equals to 4. So we know that this equals to 2, and therefore this must equal to 2. Now, what's special about that? Well, let's look at one more example, okay? Square root of 9, okay, well, 9 can be rewritten as 3 squared. And again, we know square root of 9 is just 3. Okay, maybe I have some sort of idea, but maybe not so sure yet. Okay, let me try one more time. How about square root of 25? Okay, well, 25 is 5 squared. And we know square root of 25 is just 5. Okay, I hope you see the pattern now, right? The square root of something squared, it is exactly just that something, right? That base. The square root of 2 squared is just 2, okay? Because the base is 2. Now, the key is, or the reason why this is happening is because this is a square root, okay? And we have a perfect square here. So it's like, you know, when taking the square is like you're taking one step forward, and when you take the square root, it's like you're taking one step backward. So you end up exactly at the same spot, right? So you are taking the square of the 2, and then you're taking the square root of the result. So at the end, you just went back to 2, right? You just end up with the same spot where you begin, okay? So the square root of 2 squared is a 2. The square root of 3 squared is a 3. The square root of 5 squared is 5. Okay, similarly, the cube root of 8 cube, again, same thing. Taking the cube of a number is like you're taking a step forward. Taking the cube root of that result is like you're taking the step backward. So you just end up with where you began, right? So again, the cube root of 8 cube is just going to be 8. As long as the exponent and the index match, then you're going to end up with the same, then you're just going to end up with that base. Okay, so that's what we need to know first. Okay, now let's look at how we're going to use the prime factors to solve this. Okay, so 60, I can break this into 6 times 10. 6 is 2 times 3. 10 is 2 times 5. Okay, so I can write 60 as 2 squared times 3 times 5. And therefore, root 60 is the same as the square root of 2 squared times 3 times 5. Now, from the previous page, we know we can split the multiplications, okay, when we have radicals. So this is the same thing as square root of 2 squared times square root of 3 times square root of 5. Now, again, this is nice because we are taking the square root of a perfect square. So the end result is just going to be the base, so it's just going to be a 2. Now, there's nothing we can do about these two, so we can actually merge them back, right? If we can split them, that means we can merge them. So this is the same thing as the square root of 3 times 5, which is 15. And there is your answer. Okay, that's just going to be 2 times root 15. Okay, let's look at another example for the cube root of 432. Similarly, let's do prime factorization for that. Let me divide this by 4 first. So this is going to be 108. 4 is the same thing as 2 times 2, so let me circle those. This can be, I'm not so sure. Let me just do 2. Okay, so 54. Now 54 is 6 times 9. 6 is 2 times 3, and 9 is 3 times 3. Okay, so these are my prime factors. Okay, so the cube root of 432 can then be rewritten as we have 1, 2, 3, 4 2's, so 2 to the power 4 times 3 3's, so 3 cubed. Okay, now how are we going to split this? Well, this tells me that we have 4 2's. We do not need to use all 4 of them, right? I mean, okay, let me rephrase that. We need to use all 4 of them, but we don't. When we split, we don't need to like take out all 4 of them at the same time, right? We can simply take out 3 of them. Okay, and well, obviously that's 3 cubed, so we want all of that. But don't forget, we only took out 3 right here, which means we still have 1, 2 left. Okay, so in total, that's 2 cubed times 2, so that's still 2 to the power 4. So we didn't change the value, okay? But you see how I split it, right? I split 4 into 3 and 1. Okay, now the cube root of 2 cubed, again, because the index and the exponent match, so that's just going to be a 2. The cube root of 3 cubed is going to be a 3. Now there's a cube root of 2, there's nothing we can do about that, and we know 2 times 3 is 6, and we still have the cube root of 2, and that is your final answer. Okay, so that's another way of doing simplifying radicals, right? You don't have to use perfect powers if you are not so sure about those perfect powers and how, determine whether they are factors or not. You can always use prime factorization. And of course, if you use prime factorization, you can use the continuous division as well, right? Just gotta make sure that each time you divide it by is gonna be, you have to divide it by a prime factor. Okay, so there are 2 questions for you to try, and I'll give you a few minutes, okay? Okay, 72. Let me do it quickly here. That's 8 times 9, 4 times 2, so 2, 2. And 9 is simply 3 and 3. So this is the same thing as 2 cubed times 3 squared, the square root of that. And again, we can split the 2 cubed into 2 squared. And the 3 squared, we just leave it as 3 squared. We still have a root 2 left though, right? Because we have 3 2's. Okay, so that's a 2, that's a 3. So 2 times 3 times root 2, which is going to give us 6 root 2. Okay, which I believe we did this example in the previous page, right? 6 square root of 72 is just 6 root 2. Let me check. I think we did. Did we? Yeah, we did right here. Root 72 is 6 root 2, right? No problem. Again, I show you 2 different ways of solving that question. Okay, now for the cube root of 675, we need to do the prime factorization first. I can divide it by 5. This is going to be 1, 27, 5, 5. Can divide, yes, divide it by 5, and then this is going to be 31. What? Really? 1. Oh, sorry, not 155. Oh, be careful. 135. So divide this by 5, you get, what is this, 27? And then that's 9 and 3. 9 is going to be 3 and 3. There you go. That's better. 5, 5, 3, 3, 3. So you also got to be careful when you divide, okay? Don't divide it wrong, okay? Otherwise, you will get the entire question wrong. Okay. So that means the cube root of 675 can be rewritten as 3 cubed times 5 squared here inside the cube root. This one's easy to split. It's going to be cube root of 3 cubed, and then the 3, the cube root of 5 squared. Okay, now the cube root of 3 cubed is just going to be a 3. Nothing we can do about the cube root of 5 squared, so let me just square the 5. So 3 times cube root of 25. Okay, hopefully that's what you got. Okay, now we are going to move on to the other way. Okay, we're going to do the opposite operation, right? So here, really, we're writing, when we simplify, we are converting from entire radical, right? Recall this is the entire radical, back to the mixed radical, or to the mixed radical, not back, just from entire to mixed radical. Now we're going to do the opposite direction. We're going to go the other way around. Okay, we're going to convert mixed radical to entire radical. Okay, so you can see here is the example of a mixed radical. We're going to turn this into an entire radical. Now, how do we do that? Well, think about how we get this 2 right here. If you think about the prime factorization way, this 2 came from the square root of 2 squared. Right? If you think about the perfect power way, this is just square root of 4. But I mean, come on, square root of 2 squared is just 4, right? So really, it's the same thing. Okay, so what we're gonna do is we're gonna turn 2 into a radical. So I'm just gonna write it as 2 squared, and then that's just gonna be a 7. And now remember, we can merge them together, right? So 2 squared is a 4, and that's a 7. So root 28 is your final answer. Okay, so similarly for the cube roots, if you want to turn this into the entire radical, then you turn 5 into the, okay, let me write the question actually. The 5 cube root of 3, you can turn 5 into cube root of 5 cubed, and then times the cube root of 3, which will give us 5 cubed is 125 times 3. So this is going to be the cube root of 375. Okay, so you can simply turn that whole number into a cube root, okay, by doing this procedure. Okay, so the square root of 2, 2, you can turn that into the square root of 2 squared. 5, you can turn that into a cube root of 5 cubed, okay, because this is a cube root, right? That's where you're going to turn it into a cube or a cube root. All right, so there are 2 questions for you to try. Good luck. Okay, 7 is a square root, so you need to turn 7 into 7 squared. Root 2 obviously is still root 2. 7 squared is 49 times 2, which is going to give you the square root of 98. Okay, hopefully that's what you got. 2 times cube root of 3. So this is going to be turn 2 into 2 cubed. And then you turn, or you don't turn anything for the cube root of 3. So that's that. Then you can combine them together. That's going to be 2 cubed, which is 8. And then times 3. So this is going to be cube root of 24. And that is your final answer. Okay, so hopefully it's not too difficult for you. There are questions for you to try in the textbook. Okay, let me know if you need some help. Okay, good luck.